river boat or river swimmer problems. River boat or river swimmer problems. Here we will take the river of width d. River is of width d. Now what happened? Nothing but the swimmer is starting here, otherwise boat or swimmer both are same only. Okay na? So that swimmer is starting here. He want to reach the opposite bank, then what he will do? Opposite bank, anywhere that might be. In which direction he will move? Straightly na? Vertically he will move. So whenever he move vertically, where he will reach? Exactly opposite point. For example, here home of the swimmer is there here. Here home is there. So whenever he want to reach the home, so in which direction he has to aim? Aiming should be in which direction? Did I say the velocity of the river? This is the velocity of the river, right side. Now in which direction he has to move? Left side na? Northwest direction, I'm sorry. So that in this direction he is moving. So that what happens, whenever he is moving in this direction, then what happens? River will take, see this, I am moving in this direction, somebody is pulling me that side, so that what I will do, I will go like this. I am just moving like this and then somebody is pulling me, so that what I will do, I will go like that. So whenever he want to reach exactly opposite point, then what he has to do? Nothing but he has to just travel in this direction, that is the northwest direction. Now this is the original velocity of the swimmer, otherwise swimmer with respect to the water. Obviously he is swimming in the water, no? So that what I can say, this is the velocity of the swimmer with respect to the river. Correct? Then whenever the swimmer with respect to the river is there in this direction and velocity of the river is there in this direction, then where the resultant will get exactly? Straightly, right? This is the resultant, no, here. So that what he will do, he will exactly reach the home. This concept what we call nothing but shortest path. He want to go to the home exactly opposite point, nothing but he has to cover the shortest path. How can he cover the shortest path? Nothing but whenever he is moving opposite to the water flow, then only he can cover. Why? Because already river also taking him to the home, no? Yes, he is not only the person who is swimming, the river is also making him to move to the home. Otherwise, for example, the swimmer is swimming in this direction, red color one. Then can he reach the home? No. Where he will go? Right side he will go. Why? Because swimmer is taking him. Correct? You understand? So that it will take shortest path or longest path? Longest path. He is aiming for shortest path only, obviously. But what happening? Nothing but river is taking him to the longest path. See this. If I draw like this, for example, this is 2 and then this is 3. Otherwise this is 4 and then this is 3. Then which will be bigger? Hypotenuse bigger or opposite bigger or adjacent bigger? Hypotenuse only bigger, right? So how much it will come as 5. So that this is the longest, this one is the longest, this one is the longest, correct? So that whenever he want to cover the shortest path, nothing but he has to swimming in which direction? Opposite to the river flow, correct? Not exactly opposite means not exactly like this, he has to move slantly to the river flow. Then what happens? River will take him to the opposite point. So whenever, for example, the person want to cover in the shortest time, he will take less time or more time in this path. Think properly, think properly. Less time or more time? He is moving opposite to the river flow, so that he will take less time or more time? More time, na, he has to put more effort. More effort, nothing but it will take more time. So he want to cover in the shortest time, nothing but whenever the person is swimming in this direction, then what happens? River will help him to take the other opposite bank. I am not saying opposite point exactly. Opposite bank he has to reach. Okay, to reach the opposite bank, what he is doing? Nothing but to reach the opposite bank in shortest time. I am not saying to go to the home. I just said to reach the opposite bank. Okay, then he will just swim in this direction. Then river is helping him to take to the other bank. So he will take more time or less time? Less time only, no? Yes, you understand, right? So that is the shortest time concept. Two concepts are there, very important. One is shortest path. Shortest path, nothing but in which direction he has to move? opposite to the river flow in slant direction. Then shortest time nothing but exactly he has to move perpendicularly. So that what happens, river will take him to the other bank, that's it. Not opposite point, that is opposite bank. Okay, those are the two concepts. And also one more concept is there, downstream and then upstream. In downstream what happens, less time or more time consumes. See that in downstream, whenever you want to reach, for example, this is the river I have considered, this is my initial point, this is the final point. Let me take, he is covering a distance of x. Now the river is flowing in this direction. River is flowing in this direction. Now person has started to swim. He started to swim here. So that he will take less time or more time? Less time. Why? Because for his velocity, velocity of the river is getting added. Correct? He is having two velocities, not only one velocity, he is having two velocities. Both are in the same direction. So that it is advantage or not? Advantage. So that distance is equal, time is equal to what is the formula? Distance by the net velocity. Velocity is increasing, right? Velocity is increasing. Then time will decreases. Downstream he will take less time. For example, now the river flow is there in this direction. Swimmer is moving in this direction. He will take more time. His velocity gets reduced, otherwise increased. Gets reduced. Reduced by how much? Reduced by the river velocity. Why? Because he is moving opposite to the river, na? So that the man is swimming in this direction, river is flowing in this direction. So that his velocity will get reduced by the river velocity. So that he will take more time. Obviously you know that in the words only you know that downstream nothing but less time and then upstream nothing but more time. Why less time? Because velocity is increasing. See, this velocity and then time both are inversely proportional to each other. As I increase the velocity, then what happens? Time will get decreased. Then you are saying that in upstream he will take more time. More time nothing but who is decreasing here? Velocity is decreasing. Obviously here distance, what I said, distance is same distance, otherwise different distance, same distance. So that distance is constant. So then what I can write? T is inversely proportional to the velocity. In downstream, time is decreasing nothing but velocity is increasing. Velocity is increasing nothing but getting added or subtracted? Added. Then in the upstream, you are saying that time will increases. Then what happening? Immediately velocity is decreasing. Subtraction of velocities you will get. You understand, right? You have brief idea about this, right? Then we will do the derivations. So mainly one is shortest path, another is shortest time. Next one is the downstream and then upstream concepts. These problems will be easy only. Then right, that first of all we will do the introduction, what are the components we will take. So here velocity of swimmer with respect to the river, VSR, velocity of the swimmer with respect to the river, or I can take it as velocity of the boat with respect to the water. Anything is same only. Okay, now boat and then swimmer both are same only. Now here VSR is equal to what is the general formula for it? Vs minus Vr. Vs minus Vr. What is VSR means? Velocity of swimmer with respect to the water. What is Vs means? Swimmer with respect to what? With respect to the river is finished here. With respect to the ground. Okay, for example, the person is swimming here. You are saying that his velocity increases in the downstream. Who are you? You are standing on the bank and then you are describing. Nothing but the velocity of the swimmer with respect to the ground. Otherwise with respect to the sea, the person also might be moving. He might be moving on the bike at the bank, river bank, and then he was telling, but that type of advanced problems will not come for us. For us only observation should be there. Observation nothing but man should be in the rest. Rest nothing but ground is also in rest only. So that this is the velocity of the swimmer with respect to the ground. And this is what? Velocity of the river with respect to the ground only again. From where we will observe the river nothing but we will observe from the outside only. Understand it clearly? So most of the students will get confused here only. Here in every problem they will use one more word, that is what? Still water. Velocity of the swimmer in the still water. The water might be still, otherwise the water might be flowing, but we are describing about what? Velocity of the swimmer with respect to water only, na? Here still water nothing but what they are saying, river is not flowing, so this is 0. Then velocity of the swimmer with respect to the still water is how much? Velocity of the swimmer only again. Correct? So that don't confuse by that words. If they are saying still water or velocity of the swimmer with respect to the water or with respect to the river, everything is same, that is what nothing but VSR. Correct? Then what is a VS? VS is nothing but velocity of swimmer with respect to ground or person on the bank of the river. See, they might be use any technical words in the problems, but you should get idea about that. If you don't know what is still water and then how to find still water, nothing but immediately instead of taking VSR, you will take VS only. Understand, right? So don't do that type of confusions and all. So just get idea about VSR, nothing but the velocity of swimmer with respect to the river. River might be still or river might be flowing. Okay, anything that might be. Now VS nothing but what? Velocity of the swimmer with respect to the ground. See, you don't become a swimmer. Whenever you become a swimmer, then you will think that my velocity is Vs only inside of the river. If you becoming a swimmer nothing but, then you will think that my velocity, I am just moving with Vs only. But where we are moving? You are moving inside of the water. Nothing but you are describing with respect to the water, otherwise individually with respect to the water. So you just be always observer who is standing outside of the water. That is a major technique in these problems. In the Rainman problems, the major technique is rain will fall always vertically downwards, and also whenever they said appears, feels, otherwise relative, everything is same only. That is a major technique in the Rainman problems. And also whenever you get tan theta here, you might be have with the clockwise or anti-clockwise. Always you have to describe with respect to what? Vertical only. Nothing but, for example, if I got the velocity Vrm is equals to, let me take 3I plus 5j, like this you got. Plus 5j is possible or not possible? Vrm is what? Velocity of the rain with respect to the man. Plus 5j is possible? As per me, plus 5j nothing but this is river is going, this one rain is going upward direction. No, right? So always minus will be there. And that is very important. Always minus will be there. Here tan theta nothing but, no need to consider minus here. Why? Because where you are getting the resultant? Resultant you are getting in downward direction only, no? So that why to consider again minus? So that what we can take here, just 5 by 3 only. And also always you have to take with respect to what? Theta with vertical. Nothing but what you will get here? 3 by 5 you will get. Correct? That is also one of the major technique. And also here, always the person has to hold the umbrella opposite to the rainfall. Opposite to the rainfall nothing but in this direction he has to hold the umbrella. So with vertical, how he is moving? Backward or forward? Backward nothing but anti-clockwise, forward nothing but clockwise direction. The angle might be anything. Now for example, I have the vector as minus 3I minus 5j. Then in which direction rain will fall? Vrm is equals to, I have minus 3I minus 5j. In which direction the rain will fall? Rain will fall. I am saying this one as in which direction? Southeast direction, no? Tell me now. Southwest direction. Why? Because 3I is there in this direction, minus 3I minus 5j. Where the resultant will come? Southwest direction. Correct? So as per the relative velocity, you have to find out the direction of the rainfall. Mainly that one is a main technique in the Rainman problems. While practicing the problems, I will explain that again. Okay, na? So in boat river, you have to remember that if they give with the still water, otherwise flowing water, whatever it might be, velocity of the swimmer in the still water means you have to take VSR only. Velocity of the swimmer in the river means VSR only. Velocity of the swimmer also VSR only. Why? Because where the man is swimming? Inside of the water only. They will mention clearly that velocity of the swimmer with respect to the ground. Okay, na? By doing problems you can get to know that. So here you have to remember VSR means what? Velocity of the swimmer with respect to the river. VS means what? Velocity of the swimmer with respect to the ground or on the person standing on the bank of the river. And we are nothing but what? We are nothing but velocity of river with respect to ground. Obviously there is no choice for that, with respect to ground only. Okay, write that. Boat river problems. Write each and every point. ಉದಯ್ ಲೈಟ್ಸ್ ಇಲ್ಲ ಅಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಲೈಟ್ಸು. ಆನ್ ದಟ್ ನಾನು ರಮೇಶ್, ಆನ್ ದಟ್ ಲೈಟ್ಸ್. ಇಸ್ ಡನ್. కానొస్తా ఇల్లలా ఇంతసేపు సరిపోయిందా? కరెక్ట్గానే ఉందా? సరిపోతుందా? డన్. నెక్స్ట్ డౌన్ స్ట్రీమ్. విల్ సీ వాట్ హ్యాపెన్స్ ఇన్ ద డౌన్ స్ట్రీమ్. So river is there here. In that river the person wanted to move a distance of d. Let me take from point A to B. Point A to B. This is the river direction. What is the velocity of the river? VR. Now person want to move from point A to B. The difference between them is, the distance between them is d. Let us take straight line I have taken. So he is moving from A to B. In this direction the person is swimming. In this direction he is swimming. So whenever he is swimming in this direction, what is the velocity of the person here? He is where he is swimming. There is no doubt in that. VSR only na, always he is swimming in the river only. So that VSR, general formula is what? VSR is equals to VS minus VR. So that I want only velocity of the swimmer with respect to the ground. Then what happens? VSR plus VR. So as per you are standing outside and then you are looking at the person. He is moving fast or otherwise slowly na? Fast only na, so that fast only here. You got it? Yes. Then time taken is equals to, what is the formula? D by velocity. D by velocity of the swimmer. So that D by what I can write? VSR plus VR. Correct? Huh? Then whenever the person is moving in the upstream nothing but now he is just moving in the opposite direction. Like this he is swimming. Ayyo. I am very bad at diagrams. You don't know my diagrams. So here VSR, the swimmer is moving in opposite direction. River flow is there in this direction. Enappa ಏನು ಬೇಕು? So here VSR is there in this direction and then river is flowing in this direction. He is moving opposite to the river flow. So that clearly what I can write? VSR is equals to VS minus, as respect to the person, what happening? River is flowing in opposite direction. So that minus of minus VR. Correct? Then Vs is equals to what I can get? Simply VSR minus VR. Vs, I am writing Vs directly. Okay. Then time taken, t for the upstream is equals to what I can write, distance by VSR minus VR. Very important formulas these are, very very important. Time taken for the downstream, that is, I will write it again. For downstream you will get a less time, no, less time, nothing but what happening, velocity is increasing. For the upstream the time will be more, time is more, nothing but what happens, velocity will get decreases. Copy that for upstream and then downstream, both you copy. Whatever the material I have given, that is enough, otherwise you want another material also. Whatever Xerox I have given yesterday assignment, do you want another assignment? ಅದೇ ಜಾಸ್ತಿ ಆಗಿದೆ, ಅದೇ ಮಾಡೋಕ್ಕೆ ಟೈಮ್ ಇಲ್ಲ. You want means I will give. Yes, you want, yes I will give. Don't do puja for that, okay na, you have to do. Is done? Yes, done. To cross the river in shortest path, in which direction he has to move? Opposite to the river flow. Shortest path nothing but there is no way, just this is only shortest path. This is the displacement means what? The shortest distance between the initial and then final position. Initial position and then final position. Shortest distance is how much? D only, width of the river only. So he want to cover this one, nothing but in which direction he has to move? Opposite to the river flow, so that in this direction the person is swimming. So with what velocity? VSR. Correct? Inside of the river, you remember always, inside of the river he is there means he will have always VSR only. Okay, there is no other velocity. Now river is flowing in this direction with what velocity? VR velocity. Then where the resultant will come, obviously in slightly like this you will get. Here this is the resultant actually, that is how much? Velocity of the swimmer with respect to the ground. Whenever he will travel in the river in this direction, but at the end of the day you will see him moving in which direction? Exactly in opposite direction. You are observing. Okay, whenever you observe him, for example, he started first of all his journey. You did not see him whenever he started, you have observed, and then after that you just later on he came and then you see him finally where he is in the home. Okay, but as per the swimmer, what he has done? Nothing but he has moved in this direction. As per you, where he has moved? Nothing but he has moved in the straightly, directly. So that only velocity of the swimmer with respect to the ground here. Correct? So here angle you have to find out. Nothing but with what direction he has to move. That is the angle you have to find out. For that purpose, you can either take tan theta or sin theta, anything. But always in the problems they will give VSR and then VR only, almost in all the cases. So that I want to use VSR and then VR, which will be the easy angle for us, sine angle. So that sine theta is equals to what I can write, opposite by hypotenuse, which is opposite, VR by VSR. VR by VSR. You can take tan theta also. For tan theta you want to take tan theta means opposite by adjacent you have to take, that is VR by VS. But in the problem VS will not be there. Again for VS what you have to do, VR divided by the Pythagoras law what I can apply here, under root VSR square minus VR square. Again you have to do this much. Instead of that we will find out sin theta only directly. Okay, anything you can do. So sin theta equals to VR by VSR. This is the direction in which he has to swim to reach exactly the opposite point. Otherwise to cover which path, that is shortest path. To cover the shortest path, the person has to move in this direction with what angle, sin theta is equals to VR by VSR. Okay. Then after that you have to find out the time taken. Time taken to cover the shortest path. To cover the shortest path. So what is the time formula for us? Time is equals to T is equals to d by v only, na? D by velocity only. So displacement, obviously displacement is there in which direction? Vertical direction, na? Displacement is there. So velocity also, which velocity you have to consider? Velocity along the displacement only, always. For example, you want to, for example, here in this direction the person is moving with velocity v is equals to 5 meters per second. A car is moving in this direction. It is making how much displacement? Nothing but you will always measure along the velocity only, no? Yes, you understand, right? It is covering 5 meters in 1 second. 5 meters in 1 second in which direction? In whichever the direction he is moving. For example, I am walking here. I am covering the displacement in which direction? Whichever the direction I am moving, in that direction only I am covering the displacement. Understanding, right? So that time you have to find out nothing but time is equals to in which direction displacement is there? Vertical direction. So that d by in which direction you have to take the velocity? Vertical direction only. Vertical direction, which velocity is there? Vs is the velocity. This is the time taken to cover the shortest path. This is the direction of swimming in the shortest path. Copy that. Shortest path or exactly which point, that is opposite point. Here it is the target. ಜೆಂಡಾ ಅದಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನಿಮಗೆ? Any description for that? ఏమన్నా నవ్వుకుంటున్నావు? నీ కామెడీ థಿಂಗ್ ಹಿಯರ್. ಏನು ಪ್ರಜ್ಜು, ಏನು ವಿಶೇಷ? ಮನೆಗೆ ಹೋಗಿ ಏನು ಮಾಡಬೇಕು? ಅಡುಗೆ ಮಾಡಬೇಕಾ? ಏನಂತ ಇದ್ರು ನಿಮ್ಮ ಗರ್ಲ್ ಫ್ರೆಂಡ್? I'm asking Prajwal, right? You are saying Uday. ಆನ್ಲೈನಾ? ಆನ್ಲೈನ್ ಐತಾ? ಪರವಾಗಿಲ್ಲ. We cannot control, no? We cannot control our emotions by somebody seeing like that. ಆ ಥರ ಕ್ಲಾಸ್ ಮಾಡಿದೆ ಅಂದರೆ ಎಲ್ಲರೂ ನಿದ್ದೆ ಮಾಡ್ತಾರೆ. Already we are doing that only, no? Uday? Next, to cross the river in shortest time. In this one concept will come. Any idea about that? Shortest time, nothing but the person is aiming the opposite point, but river is taking him to other place, correct? So that what is that horizontal distance, we call it as drift, YDSC na? Drift we will call it as, okay na? In current electricity you will get drift, nothing but what happens, the river will take him to reach the other point, that the horizontal distance we call as drift. I will explain that. So to cross the river in shortest time, so for that, now the river is flowing in this direction, velocity of the river is there like this. Now what happening, nothing but shortest time nothing but what he has to do, he has to aim the opposite point. He can, shortest time nothing but he can move along the river flow also, but can he reach the opposite bank? He cannot reach the opposite bank, so that there is no choice, he has to move in this direction only. But you might be get one doubt also, even he can move in this direction only na, in this direction also, so that he can move still fast, correct? But what happens at that time, he wanted to move in this direction, but he will reach somewhere here, but his home is there here. Advantage or disadvantage? Disadvantage only na. He will take less effort for swimming, but for walking it will take more exercise, so that he cannot move in this direction, only the opposite direction only he has to move. Whenever he want to reach the opposite direction, I have seen so many times in the Discovery Channel also. In Discovery Channel, they'll be going for the what we call Icelands. They'll go, and then whenever they will find some rivers there, smaller rivers will be there. So whenever they want to reach opposite point, nothing but they will move in the opposite direction only to the river flow. And also at that time, what happens, nothing but they will lose their temperature, no, body temperature, so that they want to cover very fast. They want to cover the distance very fast. They want to cover very fast, nothing but they will aim exactly opposite point. Otherwise, they want to reach in the shortest path, nothing but for example, here something here ice is not proper, here also ice is not proper. So that he want to reach exactly opposite point. If it is taking more time also, he want to reach exactly opposite point. So that in which direction he will move? In opposite direction. Here everything is proper only. They want to cover within very less time. So that what they will do? They will aim exactly opposite, so that they will reach somewhere here. Okay. If they are aiming in this direction, here they can go easily. But on the ice, on that bank also, they have to move on the ice only, no? Correct? So that always you have to aim to the opposite point only. So that what happens? River will take you to the other bank after some distance. So this distance what we call nothing but this distance we call as drift. Okay, the distance taken by the river. Who taken the distance? River only, na? Who is given? Drift is given as a gift only. So river has given the gift. Okay, so the person is moving in this direction. What is the velocity of the swimmer with respect to the river? Now river is already flowing in this direction, velocity of the river. Then this will be what for us? Velocity of swimmer with respect to what? Ground. This is velocity of the swimmer inside of the river. Okay, this is the velocity of the swimmer as a person who observed on the bank of the river. Okay, now he has to reach exactly opposite, but what he done? He has reached some other point. So this horizontal distance what we call nothing but that is a drift we call. Okay, we will get derivation for that. First of all, whenever he want to reach the other bank, just other bank in shortest time, what is the angle of aiming? Theta is equals to how much? He want to reach just opposite bank. Okay, very fast nothing but shortest time nothing but he has to aim in which direction? I am saying straightly nothing but 90 degrees with respect to the river bank, otherwise 0 degrees with respect to the vertical. Hello. Here VSR nothing but what? Velocity of the swimmer with respect to the river. He want to reach the opposite bank in very short time. Then nothing but what he has to do? He has to aim exactly northwards. Otherwise 90 degrees with the river bank. Otherwise 0 degrees with the vertical. Anything you can consider. Now he is moving in this direction, river is taking him here. So what is that distance we call as drift, we call it as. Now the angle already you know that how much angle, that is 90 degrees. Then I want to find out the time here, shortest time. Shortest time, what is the time formula for us? Distance by velocity only, na? Distance by velocity. So that how much distance he is covering? Obviously width of the river only. So that d divided by, along with d who is there? Which velocity is there? VSR. That might be any velocity, but velocity should be there along the distance only. Okay, so that here what I can consider that as VSR. Now here VSR is equals to what I can write from this triangle? Vs square is equals to VR square plus VSR square. Then VSR is equals to what I can write? Under root Vs square minus VR square, as per the requirement. Whatever they have given VSR means directly you take VSR only. If they have not given VSR, they have given velocity of the swimmer with respect to the ground. At that time, instead of VSR, what I can write? D by under root Vs square minus VR square. This is the shortest time to travel to the opposite bank. Then whenever he want to reach the opposite bank in shortest time, then what he got extra? Drift he got. So that drift is equals to, drift x is equals to what I can write, tell me? Drift is equals to what I can write? Distance is equals to, what is the formula for us? Velocity into time. So velocity nothing but we don't know horizontal velocity. Correct? So at that time you can write the horizontal velocity only, there is no problem in that. But I will tell you a shortcut method. If I take this as angle theta, okay, from the smaller triangle, tan theta is equals to what I can write? Smaller triangle, tan theta is equals to VR by VSR, opposite by adjacent, so that VR by VSR. From the bigger triangle, tan theta is equals to what? See, from the bigger triangle, this is the bigger triangle, no? X by D. X by V, no, you should not take VSR. Why? Because you are describing about the distances only. X is distance, D is distance. VR is velocity, VSR is velocity. Same things only you have to take always. Then both are equal to each other here. Then what I can write? X by D is equals to VR by VSR. Then X is equals to VR by VSR into D. That is the original formula of the drift, that is X is equals to how much? VR by VSR into D. Very important concept. Very, very important. If they have not given the VSR means again you have to write this formula. Okay. That is you can write as what? X is equals to D into VR by under root Vs square minus VR square. Done? Copy that. Everything you understood, right? Shall I explain again? Understood, right? Yes. I think evening class only nice than afternoon class, no? Yes, we will do that only. But tomorrow afternoon will be there, physics class. Evening chemistry study hour. Exchange. Today only I exchanged. Give me that Xerox, whatever they have given. Otherwise, no need everything. I have in phone. Till here weekend syllabus, till riverboat problems. Finished? Huh? Write a problem. A person can swim. A person can swim. Not yet finished. Make it fast. Done? A person can swim in still water. A person can swim in still water at 5 meters per second. At 5 meters per second. Full stop. He moves in a river of velocity 3 meters per second. He moves in a river of velocity 3 meters per second. Till here what they have given? VSR and then VR. Yes, very good. Then first downstream and then upstream by the same distance. Then find ratio of times. Find ratio of times. 30 seconds problem. Very good, Varun. One is to 4, yes, very good. Thirty seconds means if I leave, you will take 30 minutes only. 1 is to 4 is the correct answer. Why this much time? See, T down. What is the formula for T down? D divided by V. D divided by VSR plus VR. Then upstream. T up is equals to what is the formula? D by VSR minus VR. This is only a formula. So that they are saying that velocity of the swimmer in still water, VSR is equals to what is the formula? What is the value they have given? 5 meters per second. Velocity of the river is how much they have given? 3 meters per second. So that same distance or different distances are? Same distance. So cancel D. Then T down by T up is equals to VSR minus VR by VSR plus VR. So that minus VR nothing but how much? 2 by 8. So that 1 by 4 is the answer. That's the correct answer. Write one more problem. The velocity of water. Next problem. The velocity of water in a river is 2 kilometers per hour. The velocity of water in a river is 2 kilometers per hour. While width width is 400 meters. 400 meters, full stop. A boat is rowed. A boat is rowed. Rowed, R-O-W-E-D. Boat is moving. A boat is rowed from a point. Rowing always. Aiming opposite point. At 8 kilometers per hour. At 8 kilometers per hour. Of still water velocity. Then find the drift on reaching opposite bank. Very good. Very good. You have to find out the drift. Yes, very good. They have twisted the question. Instead of giving direct sentences, they have twisted. So that they are saying, first of all, velocity of the river. Velocity of the water in the river is how much? What is that they have given means? VR na? Velocity of the river is 2 kilometers per hour. Then after that what they said? While the width is D is equals to how much? D is equals to 400 meters. Then a boat is rowed from one point. What is it? A boat is rowed from a point, rowing always aiming the opposite point. What is the velocity of the boat they are saying? Velocity of the boat in the still water is they are saying as 8 kilometers per hour. Now you have to find out the drift on reaching the opposite bank. Drift formula is what? VR by VSR into D. That's it. Direct formula. Nothing is there. Here you will get as 100. And no need to convert into kilometers per hour into meters per second. Why? Because in ratio only they will get cancel only here. There is no need to convert. How many of you got the answer? 100 meters? Yes, good. Almost. Very good. Then next problem. A man can swim. In still water. A man can swim in still water at a speed of 4 kilometers per hour. Full stop. He desires to cross a river. Flowing at speed of 3 kilometers per hour. In the shortest time interval. Full stop. If the width of the river is 3 kilometers. If the width of the river is 3 kilometers, then find time taken to cross the river. And the horizontal distance travelled. How much? No. And the horizontal distance travelled. Do that properly. Horizontal distance means what you have to find out? Drift, no? But Pramod, you are very advanced. You have gone to projectile motion then only. Still 2 days time is there. Answer is 1/4, 9/4 I think. 9/4 width, very good. 3/4 is time taken. Shortest time, no, they are saying. What is the shortest time formula? Shortest time formula is what? T is equals to D by VSR. D by VSR. So that D by VSR, nothing but D is how much? 3. VSR is how much? 4. They have given 4. Yes, very good. 3/4 and then 9/4. The answers are 3/4 and 9/4. 3/4 is the time taken, 9/4 is the drift. Is done, everybody? They are saying that the person is moving with what speed? Velocity of the swimmer is what speed they are saying? Swimmer in the still water is 4 kilometers per hour, no? Velocity of the river is how much? 3 kilometers per hour. Width of the river is how much? D is equals to 3 kilometers. Now he is desired to reach in the shortest time. Shortest time, nothing but second case. In second case, what will get? How the person is moving? If you are not able to remember the formulas, remember the diagram. That will give you the answer. So in second case, shortest time, nothing but in which direction he has to move? Opposite direction, exactly. So that opposite direction he is moving like this. He is covering a distance D, moving opposite direction with VSR. Then what is the time taken? Shortest time taken, T is equals to D divided by VSR. D by VSR. Then D is 3 and then VSR is how much? 4. So that 3/4 hours are seconds are what is that? Kilometers per hour, kilometer nothing but what is remaining? Hours is remaining. Then after that they are asking about the drift, horizontal distance. Drift is equals to what is the formula for us? VR by VSR into D. VR is how much? 3. VSR is 4. 3. 9/4 kilometers. Not meters, that is kilometers. Clear? That's the answer. Now little twisted question. Take that. The velocity of boat in still water is 10 meters per second. 10 meters per second. Full stop. If water flows in the river, with a velocity of 6 meters per second, then what is the difference? In times taken? Aishwarya, sit there. What is the difference in times taken to cross the river in shortest path and shortest time? Width of the river is 80 meters. They are saying difference between shortest path and then shortest time. Time difference between them. Very good. Varun is in jet speed today. ಪಲ್ಲಿ ಚೆನ್ನಾಗಿ ವರ್ಕ್ ಆಗಿದೆ ಅನಿಸುತ್ತೆ. He is not even writing the problem. He is waiting for the question, final question what I will ask. He is taking the values and then he is waiting for the question. Shortest time minus shortest distance. Shortest distance minus shortest time. They asked?
Shortest path and shortest time.
Yeah. Shortest path and then shortest time. Shortest time minus shortest path you have to take. Ayyo, I am saying in reverse only always. Shortest path minus shortest time, no? First, yes. Time taken in shortest path minus time taken in the shortest time. 2 is the answer. 2 seconds is the answer. See that properly. Shortest path, nothing but what is the formula of T? T is equals to D by Vs, no? Did they give Vs value? They have given VSR value. Correct? Whoever taken that as Vs, you will get the wrong answer. Under root squares. Two seconds is the correct answer. Yes, very good. Two seconds is the correct answer. See that they are asking the time difference between shortest path and shortest time. Given is what? VSR is equals to how much they have given? 10 meters per second. VR is equals to what? 6 meters per second. Now time difference between shortest path and then shortest time. So shortest path formula. Do you remember that shortest path? Shortest path nothing but he has to move in which direction? Slantly, right? Slantly VSR means straightly who will come? Vs will come. So that D by Vs. Did they give any Vs value here? No. So that D by, instead of Vs what I can write? Under root VSR square minus VR square. D is how much? 80 I guess. And under root VSR square. 100 minus 36. So that what will get here? 64. Root 64 nothing but 8. So time is how much? 10 seconds. Then in shortest time formula, he is aiming straightly like this. He is aiming. So that what is the formula? D by VSR. So that D by VSR you will get. D is how much? 80. VSR is how much? 10. So what will get here? 8. Then time difference between them, delta T is equals to 10 minus 8 you will get. That is how much? 2 seconds. That's the answer. Clear? Yes. Right, last problem. You have to work on this. Next problem. A boat takes 4 hours boat takes 4 hours to travel certain distance in a river in downstream and it takes 6 hours to travel the same distance in upstream. Full stop. Then find the time taken by the boat to travel the same distance in still water. First of all, downstream given is how much? 4 hours. Upstream is given as 6 hours. Asking for finding the time in the still water. Nothing, they have not given any velocities, nothing. Little lengthy problem, but you can get the answer easily only. Stop that now.